Hello, I have prepared this lecture for the students of BSc Honours Physics 6 semesters of Department of Physics, Aligarh Muslim University, Aligarh, who are attending the course Nanomaterials and Applications. In this lecture, I will briefly discuss the applications of quantum dots in light emitting diodes. As you already studied some low dimensional systems like quantum wire, quantum well, quantum dots, and there are tremendous or variety of applications of all low dimensional systems. If you talk about the applications of quantum wires, then they are used as electron waveguide and switchable high-speed lasers. And some interesting physics emerges when quantum wires are used in transport experiments. They can also be used in transistors and sensors. If we talk about the applications of quantum well, then they can be used as active semiconductor laser, which enjoy widespread commercial use in optoelectronic applications, ranging from high power sources for medical therapy, material processing, laser printer, and they can also be used pump for solid state lasers. Quantum wells can also be used in photodetectors, modulators, switches, etc. And if you talk about the applications of quantum dots, then they basically the quantum dots are semiconductor particles of few nanometer in size, having optical and electronic properties different from larger particles. And due to this important property, they have potential applications which include single electron transistors, solar cells, lasers, single photon sources, quantum computing, medical imaging, etc. Their small size draw for some quantum dots to be suspended in solution, which may lead to use in inkjet printing and spin coating. The important thing that the devices based on quantum dots are less expensive and less time consuming. Now we will discuss the application of quantum dots for light emitting diodes and solar cell, but first we take the application of quantum dots in light emitting diodes. So before I start the main topic, let me introduce light emitting diodes, what actually they are and what are the main components and their working principle, and what are the advantage and applications of LED. So what actually the light emitting diode? The light emitting diode is a two lead semiconductor light source, and it was discovered in 1962 by Nick Holoniak, who has come up with an idea of light emitting diode, and he was working for the General Electrical Company. The LED is a special type of diode, and they have similar electrical characteristic of PN junction diode, as you already studied in your analog system and applications course that how the PN junction diode works. So LED allows the flow of current in the forward direction and blocks the current in the reverse direction. The LED occupies very small area which is less than 1 millimeter square, as you see some LED light in market or industry that you can imagine that how small they are. The applications of LED used to make various electrical and electronic projects. The light emitting diode is nothing. It is a PN junction diode, and it is especially doped diode and made up of a special type of semiconductor. When the light emits in the forward bias, then it is called light emitting diodes. Now, how does LED work? The light emitting diode simply, as we know, it is a diode. Then when this diode is forward biased, then the electron and holes are moving fast across the junction and they are combining constantly, removing one another out. Soon after the electrons are moving from N-type to the P-type silicon, it combines with the holes and disappears. And it makes the complete atom and more stable, and it gives the little burst of energy in the form of tiny packet of photon of light. The power supply across the PN junction makes the diode forward bias and pushing the electron from N-type to P-type. As you can see that in the last slide, the figure, the N-type silicon was in red color and P-type silicon was in the blue color. So pushing the holes in the opposite direction. Electron and holes at the junctions are combined and the photons are given up as the electron and holes are recombined. There are various type of LED systems depending on the semiconductor material used. And if you use the gallium arsenide, then they emit the infrared. And if we use gallium arsenide phosphide, then they emit red to infrared or orange color. So in this way, you can see that how different color LED emit the light by using the different semiconductor materials. So now the basic principle of LED, the basic working principle of LED is based on the quantum theory. The quantum theory says that when the electron comes down from the higher energy level to the lower energy level, then the energy emits in the form of photon. The photon energy is equal to the energy gap between these two energy levels. As I already mentioned, that this is the basic condition to emit the photon, that the energy of the photon must be equal to the energy band gap of the semiconductor. If the PN junction diode is in the forward bias, then the current flows through the diode. The flow of current in the semiconductor is caused by the both of flow of free electrons in the opposite direction of current and flow of electrons in the direction of current. Hence, there will be recombination due to the flow of these charge carriers. The recombination indicates that the electrons in the conduction band jump down to the valence band. When the electron jump from one band to the another band, then the electron will emit the electromagnetic energy in the form of photons. And this photon energy is equal to the forbidden energy gap. For an example, if you take the energy of the photon, that is basically the product of Planck constant and frequency of electromagnetic radiation, as you can see, E is equal to h nu or hf, where h is the Planck constant and f is the frequency of the electromagnetic radiation. In general, silicon germanium semiconductor, this forbidden energy gap is between the conduction and valence band, and such that the total radiation of electromagnetic wave during radiation is in the form of infrared radiation. So we cannot see the wavelength of infrared because they are out of our visible range. That means if you see the germanium silicon semiconductor, this is in the invisible range. So infrared radiation is said to be as a heat because the silicon and the germanium semiconductor are not direct bandgap semiconductor, rather than these are indirect bandgap semiconductor. But in the direct bandgap semiconductor, the maximum energy level of the valence band and the minimum energy level of the conduction band does not occur at the same moment of electron. And therefore, during the recombination of electrons and holes, our migration of electrons from conduction band to the valence band and momentum of the electron band will be changed. So now the applications and advantages of LED. There are many applications of light emitting diodes. For example, LED is used as a bulb in the homes and industries. The light emitting diodes are used in the motorcycles and cars. These are used in the mobile phones to display the message, and they can also be used in the traffic signal. And advantage of LEDs are that the cost of LED is less and they are very small. By using the LEDs, the electricity is controlled or minimized. The intensity of the LED differs with the help of the microcontroller. Now we come to the main point, that is the quantum dot based LED systems. So quantum dot light based light emitting diodes represent a form of light emitting technology that are regarded like a next generation of display technology after the organic light emitting diode display. Quantum dot based LED are different from liquid crystal display, OLED, and plasma display due to the fact that quantum dot LED present an ideal blend of high brightness, efficiency, flexibility, and low processing cost of organic light emitting diodes. So quantum dot LED show theoretical performance limit which surpass all other display technologies. Quantum dots obey the quantum mechanical principle of three-dimensional confinement of charge carriers that determine novel quantum phenomena and tunable optical properties which are sensitive to size, shape, and material composition of the quantum dots. Quantum dots have an energy gap that decides required wavelength of radiation. So absorption and emission spectra. The band gap energy increases when you reduce the size of the quantum dots. So therefore, the color of light which quantum dot emits is directly connected to its size. The bigger dots cause longer wavelength, lower frequency, and redder light, while the smallest dot produce shorter wavelength, higher frequency, and blue light. It means this is because of size-dependent property of the quantum dots. Means if you increase the size of the quantum dot, the band gap decreases. If you decrease the quantum dot size, then band gap increases. This dimension dependence permits the modulating of the bandgap energy by varying the size of the quantum dots. So therefore, quantum dot technology is used to filter out light from LED to backlit LCD systems. Now, the basic thing is that what is the structure of quantum dot based LED? So due to the multiple advantages of using quantum dots and their applications in optoelectronic instruments, the scientists have created quantum dot LED with the improved efficiency. So quantum dot LEDs are a form of light emitting technology for creating large area display and could have application for TV, cell phone, and digital cameras. the if we see the main structure, then classical quantum dot LED is composed of three layers: one inner layer of quantum dot as an emissive layer, one outer layer that transport electrons, and one outer layer that transport holes. It means it is composed of mainly three layers: one layer of quantum dots, one layer of hole transportation, and one layer for the hole transportation. So the researcher addressed these requirements by using a layer of 6 nanometer cadmium selenide quantum dots and an electron transport layer made of zinc oxide nanocrystals. And the researcher fabricated 4 different versions of quantum dot LED using a different quantum dot film thickness 15 to 60 nanometer. After applying an electric field on the outside layer, the electrons and holes shift in the layer of quantum dots, where they are captured by quantum dot and recombine, emitting photons. Due to multiple advantage of using the colloidal quantum dots, the colloidal quantum dots are a promising way for making quantum dot LED. It means in the quantum dot layer, we can use the colloidal quantum dots, in which the quantum dots are suspended in certain solvent. So they also give very good advantage. A great effect of an increased recombination efficiency is obtained by constructing an emissive layer in a single layer of quantum dots so that the electrons and holes may be moved directly from the surfaces of electron transport layer and the hole transport layer. The important parameter which is used in quantum dot based LED is the external quantum efficiency, which is basically the ratio of number of photons to the number of electrons emitted. So the important feature of the quantum dot based LED are they can be not only reduce the consumption of energy but also show the high color purity. Some studies reported that quantum dot LED exhibit the ability to be more than twice as power efficient than organic light emitting diodes at the same color purity. Quantum dot LEDs exhibit pure and saturated emission colors with narrow bandwidth. In quantum dot based LED, the emission color is powerfully directed by the dimension of the used quantum dot due to the confinement effects. It has been proven that quantum dot LED present a 30 to 40% luminance efficiency advantage above organic light emitting diodes for the same color input. Thank you very much.